right, hello everybody, and welcome to Spatial Viz, Spatial Visualization with me, Mo Woods. First week, I forgot to record my Zoom meeting, so I'm going to quickly re-record myself just kind of going through the motions with, nobody, so I can give at least some sort of video feedback for those of you who may have missed the first week. In the future, I'll probably try to capture the Zoom meetings that we have so that it's a little bit more interactive. But getting started here, the spatial visualization workshop is going to be broken down into about 6 weeks of material, right? Today we're starting off with orthographic views. We're going to have a couple of opportunities here throughout the workshop to retest and see how we did with that PSVT, the Purdue Spatial Visualization Test, the one that says, take a shape and rotate it this way, and now how does this shape also rotate that way, right? We're going to have a couple more opportunities to take that test, but for now, we're going to be focusing on a few lessons in between now and then that kind of build up to those concepts. So, Orthographic Views is today. Just a quick reminder that we're going to be holding these workshops twice weekly, right, for about 45 minutes, starting at 6 o'clock on Zoom for the next 6 weeks. Right? You only have to show up for one of the 2 days each week, right? Monday and Tuesday are going to have the same content, so no need to worry about coming to both. Getting a 20 out of 30 or higher is 5% of your semester grade. So anytime we retest, if you get above 20 out of 30, then that's fantastic, right? We'll give you that 5% of extra of your grade. But also keep in mind that just by attending all of these workshops, right, and participating in them, right, you'll be eligible for 3% of extra credit over your semester grade, right? So you do have to attend all 6 of them, right? But we want to make sure that you're, getting paid for showing up, right? You're learning a new skill, and that skill is useful for you, I hope, but it's also something that we want to reward, right? So anybody is able to attend and grab those points of extra credit for our workshop. If you have any issues come up about attendance, right, make sure that you email me, preferably beforehand, so that we can arrange something else, right? Hopefully I can send you these Zoom videos and make sure that you have everything that you need in order to accomplish the assignments each week, okay? But I'm here to help you, and I want you to learn a new skill and really have a lot of fun with it, okay? So let's get going on here. Hopefully you all are familiar with the fact that I've been corresponding with everybody in the Gene 1400 and ASEAN 1403 and all sorts of variations of that through Canvas, right? If you haven't heard from me recently and you're seeing this video, that's odd, but just making sure, right? Talk to me, look out for my correspondences on Canvas, right? I want to make sure that you aren't in the dark with anything. One other thing that I'll kind of plug right here is that if you find yourself wanting some practice on this spatial viz stuff, there is an app. It's not developed by us, but it's something that goes very much in line with the things that we teach. It's by a company called eGrove, but you can download that on Apple and Android. It's a spatial visualization practice kind of gamified app, so I suggest grabbing that along with the Canvas app if you have not already done so. Okay, so orthographic views. This is the first lesson in our 6-week spatial visualization workshop series. So, getting started here, what are orthographic views? Well, let's break down that word together, right? Graphic usually means something like a picture, right? Whereas ortho is typically more like, it's like, what is ortho? Ortho is similar to a word like perpendicular or normal, right? Ortho means that we are going to be looking straight onto a face of this object, right? So if we were to say, so in order to do that, right, you're going to hear me say this almost every single time that we hold a spatial visualization workshop. This is the key tenet, the most important rule of what we're going to be doing. And that one rule is start by defining a coordinate system, right? In order to describe what we're doing, we need to very carefully, create some sort of a reference, right? So that we know what we're talking about and we can say what we're talking about consistently. So, how do we do that? Well, let me first pull up my my pen. Here we go. There we go. Okay. All right. Let me pull up my pen. And so let me just start with this, right? So let's say that the origin of this coordinate axis that I'm going to be creating right here is at the back corner of this shape that we can see, right? So really, it's kind of just hovering right. It's kind of just hovering back here, right? But that's behind everything that we can see. And so then if we were to create axes, right, they would be behind our part for a while, but then they would come out, and let's call this one the yellow axis. We can call this one the red axis, right? It doesn't really matter what we're calling it. We just need to be consistent, right? So it could be the smiley face axis, it could be the I don't know, hamburger axis, whatever you want to call it, right? And this is the blue axis. So, okay, so and then let's furthermore define which axis we are going to be talking about, right? So I'm going to draw a little eyeball here, right, to represent me looking down the down this X or this yellow axis, right? So this arrow is poking us in the eye, right? This yellow axis is the view that we are going to be looking at. And so if we were to call that, well, define that over here, right? The axis, or by looking at down this axis, the face that we are going to be able to see, right? The faces, I should say, are going to be, well, let's see, this face, right? And this face, right? Because all of the other faces are kind of parallel, right? They're in the same plane as this arrow, right? This axis. And the orthogonal planes, right? These faces that are normal or perpendicular or orthogonal to this yellow axis are right here, right? Similarly, if we were to look down the red axis, right, we would be able to see this face and this face, all of the top faces, right? And then lastly, the blue axis would give us this face and this face, right? Okay, so I'll clear my workshop here just a little bit here, right? So we're looking at these two yellow faces, right? And so first we need to actually translate our yellow axis, this yellow view, into an orthographic coordinate system, right? So if the yellow axis is pointing out towards us, it looks like this, right? Here's the end of the arrow pointing into our eye. And then we can draw our red axis. Where does it go? Well, it goes up with respect to the yellow axis. That's fine. So we can do this, right? There's our red axis. And then our blue axis goes to the left of that if the red axis is up, right? So there are our coordinate axes projected into this yellow view, right? So this is a yellow view, right? And even more so, right? Even more accurately, right? If you were to, be calling this an x-axis, say, you might be very okay. In fact, you might insist on saying that, you need to designate whether or not it's a positive or a negative view. And so if we're looking down the positive or the actual, arrow itself, right, I would say that this is a positive yellow view, right? Much like it would be the positive x-axis versus the negative x-axis, for instance, right? So we've got our positive yellow view. The yellow axis is pointing towards us. Red and blue are pointed up and to the left, respectively. So let's actually start doing this. Right? So I would suggest a couple things. Right? Let's see. I need to find a good color that we can see. I'm going to choose green here. Right? If we want to start drawing these things, we need to start in a logical place, right? And I think that typically the origin is a good place to do that, right? So if we were to project, what vertex, what corner of this shape is aligned, is projected with on top of the origin, right? And what that means is in the yellow view, right? Which of these corners overlaps the origin and is on the yellow axis, right? Like this. Where is that point? Well, it's this one, right? This corner is on the yellow axis, and so is the origin, and it's the only corner for this shape, right? That's on there. And so let's start here, right? Let's start in this corner that overlaps the origin, right? So first thing I want to do is I want to implore you to use rigorous terminology, right? We could say that it goes up and then to the left and then down and to the right and whatnot, but as we start to, if we were to rotate this coordinate frame reasonably so, right? If we were to put the red axis coming out to the right side and then the blue axis up, there's nothing wrong with that, right? It's just an orientation skew, right? But then we kind of lose track of this up, down, left, right kind of a thing, right? So let's be rigorous, much like we would be doing in a plotting in math, right? So what I want to do is I want to convey what I'm doing mathematically. So let's do that, right? I'm going to go let me get a better pen. Let's see. I'm going to go positive 1, 2, 3 in the, let's see, that's the red direction, right? The red direction is up, so positive 1, 2, 3 in the red direction. Then I need to go, let's see, that's positive 1 in the blue direction. Okay, so that's 1. Good. Negative 2 in the red direction. Okay, so that's fine. Right? No reason to get confused between, whether or not this is X, Y, Z, red, blue, green, happy face, whatever, right? Still the same terminology. Negative 2 red. Let's see, this one would be, again, in the positive blue direction. So 1 positive blue. Another negative red, 1 minus 1 red, and then we're going to go back 1, 2, that's negative 2 blue, right? And that's our face, right? I've created these little knobs to kind of make some semblance of a grid, right, so that we can see the separation between those two, right? But here we go, right? We've got our part. We've got our face, this green backwards L face, right? Great. Well, so we said that before there were two faces that we could see, and I'm going to slightly change my pen color just so we can see it, right? But that second face was this one right here, right? And so before we get too far ahead of ourselves, right, we need to find a place to start. And how would we define that place to start? I would say that maybe if we were to, draw this face like this, we might want to start in this corner right here, right? So how would you describe that corner? Well, in math, right, using normal XYZ coordinate system, you might report it as a pair of coordinates, right? And so I would say that the red coordinate, right, is up 1 in the red direction, 1, and the blue direction is 1 as well. There's technically a yellow direction too. There's some depth, but we're not worried about that, right? This is an orthographic view. So let's start there, right? If we start at 1, 1, or 1 red, 1 blue, that brings us to this point on our orthographic view, right? This point projected back here on our this kind of 3D view, right? And so then let's do exactly what we just did before, right? From this offset point. So we're going to go +1 in the red, +1 in the blue, -1 in the red, -1 in the blue, right? So 1 in the red, 1 in the blue, -1 in the red, -1 in the blue, okay? Cool. And that's it, right? This block here is represented by this block here, right? Great. Okay. So, and we are pretty much done, right? These are the only faces that we should be able to see from this view. And so if I were to clear off my scribbles, right, and actually use the slides that I use, right, we start with a grid, an orthographic grid, right, something that you are probably very familiar with, this kind of, dotted 90-degree grid. We can create our coordinate system, right? In this case, I used X, Y, and Z. Again, it doesn't matter whether you use colors, however you designate it, as long as you have a name for it. And then, the X view, the Y view, the Z view, all positive views, because we're looking down those axes, would be represented like something like this. And you can review the slides here at your leisure. I won't go too far into these, right? We just saw how the, I guess it would be the right view was created, right? Okay, well, so then where do we go next? Well, let's take a look at a new shape where I have something new for you. So let's just pretend that we're going for this, right? Just like we were before. I'm going to choose to draw my my coordinate axis from the back here, right? Again, kind of from behind, and then it comes out here. I'm going to call this yellow because I can. I'm going to call this one blue, again, because I want to. And then the red axis comes up here, and we go like this, right? So our coordinate system is behind this part, right? We have our red, blue, and yellow arbitrarily defined. Let's say that I wanted to put my view, my eyeball, right, on the yellow axis, but back here, right? It looks kind of like this yellow eyeball is at a three-dimensional, like looking from a bird's eye view, right? But that's not what we're doing, right? That's not what we're worried about. We're looking at orthographic views. So what this really means is that I'm looking down the back end of this yellow arrow, right? Which would make this the negative yellow view, right? Okay, I just so happened to pick yellow twice. That's by coincidence, right? But that's okay, right? So if this is the negative yellow view, then, well, let's put our coordinate axes up, right? So here's the red, and the blue, again, comes off to the left, okay? We are doing something very similar to what we had before. And then, well, let's talk about what features we'll be able to see. We can't really see what we're looking at now, right? We are kind of inferring the fact that there's nothing more exciting than these three blocks, right, in this face behind here. But if you were to describe that, right, based on this edge that we can see from our view right now, based on this edge, we should be drawing something that looks kind of like a staircase, right? The back edge is going to come back here along the red axis and the blue axis, and it's just going to be this singular face, right? Okay, well then let's do that, right? I'm going to erase this dotted line. So again, just starting from the origin, being very rigorous in our definitions, right? Where do we start? Well, let's do 1, 2, 3 in the red. That goes from up here to 3. That's behind it, right? Then +1 in the blue, -1 in the red, right? This is +1 in the blue, -1 in the red, +1 in the blue, right? -1 in the red, +1 in the blue, -1 in the red. Takes us back down to here, to the blue axis. And then, again, -3 in the blue, right? So, again, not a terribly complicated process, right? But practice makes perfect, and we'll see that, it takes some practice to get used to this, right? But this is all we can see right now, right? But I would argue that this doesn't really give us an accurate picture of what's going on, right? And I think that you would agree that, if we had X-ray vision, we would be able to tell that there is something else back here that we should be able to see if it wasn't for, this staircase kind of blocking our view, right? It is orthographic. It is our view is normal to this face, right? So we should be able to see it, except for the fact that it's blocked. And so this is where this rule comes in. Hidden edges are shown using dotted lines. And so let's describe that, right? This corner is the corner that is overlapping the y-axis, right? It's projected onto the origin, and so let's start there. Right? It starts back here, and I'm going to draw this as dotted lines, right? So that's positive 1 in the red, positive 2 in the blue, minus 1 in the red, minus 2 in the blue, right? There's this kind of dotted line feature hidden behind this green staircase, and we can show that, right? Show that it's not only there, but it's also behind our staircase, right? By using this dotted line feature, right? The last thing about this, though, is, well, okay, let's walk through this, right? And in fact, again, I'll erase all my lines, right? So let's do this in the nice, clean slides version, right? Direct or draw coordinates over the part and name them. Okay, nice. X, Y, Z. Very good. Choose your view and draw the coordinates on the grid. Very good. Minus X view, which is that negative yellow view again, right? This is ended up being back here, right? Where we were looking down the back end of this arrow, right? And then, let's see. Draw lines where there are edges. Change the plane. Okay, so we draw this staircase thing. So far, so good. Hidden edges are shown using dotted lines. Okay, good. We are on the right track. This is that back piece right here that's floating around. And then, rule number 5, solid lines trump dotted lines. Okay, well, all that means is that solid lines will always win over, right? They'll always overlap and overwrite these dotted lines, right? So we're not going to, worry about dotted lines over solid lines, right? It's just solid lines win. The only time that we see dotted lines is when they stand alone, right? And that's it. Right? So this is our negative X orthographic view of this shape. Okay. Now, now I'm going to ask you to, do a exercise sheet, right? This is, there's kind of a 45-minute lecture of what we're going to be doing, followed by me asking you to take over the next week an hour of your time to practice this skill, right? And we'll get to that here in just a minute. But just to really drive this point home, right? I want to show you my favorite method of thinking about how to do this, right? Because it's fairly simple, but I can describe it in words what's going on. However, actually putting it into practice can get a little bit challenging, right? In fact, the first time that I made this little example, I did it wrong. So I mean, we're all human, right? Let's figure out a new method that might help us out, right? So let's talk about this. So I've got this shape, right? These are all the same blocks. I've just colored them for the sake of this exercise, right? Let's say that I wanted to do the negative yellow view, right? So again, I'd be looking down this axis, down the back end of this yellow axis, right? Such that my blue axis is up and my red axis is going to the right, right? First thing I'm going to do is I'm going to draw the first layer, the closest layer to me, with solid lines, right? So that would be the green layer, right? It's the first layer of the onion. I draw that, and these two faces, right, are just kind of hovering, floating out here in space, right? Okay, then I'm going to move on to the second layer, and I'm going to draw this layer completely with dotted lines, right? We'll see why, but so this is this kind of 3-block thing floating up, starting at let's see, that would be 2, 0, right? 2 in the blue, 0 in the red. Up here is where that corner is. Then the purple one, okay, similarly. It's just floating up here in space. It's 2 blocks, again, using dotted lines. Then I'm going to make a composite of all of these, right? One layer at a time. So I start off with the green layer, right? This is what we just made back in layer 1. I'm going to write it over here. And then I'm going to overlap the stuff that I have in orange, right? here we go. Okay, I've got these things, and what I'll see here is that this is my rule, right? Lines outside of anything that aren't enclosed within any other shapes become solid, right? Those are outside lines, and so they are going to be visible, right? And I would argue that I can see, yes, this line and this line, right? So those should be visible and therefore solid, right? So I'm going to make that one solid and that one solid. Very good. And then lines inside of other shapes are going to stay dotted, right? Because we can't see this back edge of this orange layer, right? And so therefore it's going to be a hidden edge. I'm going to add on the purple one, right? Everything that the purple has to add, right? Technically, the purple has some features like this, right? That kind of come down in here, but those are trumped, right? Those are overwritten by existing solid lines, right? Since this purple, block up here is completely outside of everything, right? It is visible, and so therefore it should become solid, and we are left with our part, right? Our orthographic negative yellow view of our part, okay? And that's it. So, about the assignment, right? So this is the exercise sheet that I have created for you. And what does it entail? So what is your responsibility? Well, the first thing is that there is a bit of a review, right? Hopefully just to give you some background in case, you come back to this a couple days later and you say, I don't quite remember what we talked about, right? Here's a little bit of a background, right? Some examples that I find kind of fun, and then some tips and tricks, right? This is where we talked about my layer by layer method, right? Following that, a list of the materials that you need, right, in order to build on this and actually do this exercise, right, either in person or over the internet, right? I don't want to necessarily make you reliant on having a printer, say, so I have some resources that you can use as online tools. And these are the exercises. In fact, all the way down here, you can choose your own adventure, and I want you to, right? The reason why I give you so many choices over a period of an hour is not so that you can do every single one of them. If you want to, that's great. But what I want you to do is, start working through these exercises. If they really make sense, if you feel like you're being challenged, but they also are, kind of making sense. Oh, okay, I see how this is working, right? When I use this specific exercise in the workbook, or maybe the CAD exercises that we use that are more visual examples on the computer, right? I want you to work through these and just practice. Have fun with this. Practice with something that makes sense to you, that speaks to you, and that challenges you. I'm only asking for an hour of your time on this, and it doesn't all have to be at the same time. The thing that I want you to do is that when you're done, save all of your materials, right? If it's on the computer, take some screenshots of it. If it's on paper, take some pictures with your phone and upload them to the Canvas course that I have, right? There's an assignment labeled Assignment Week 1 Orthographic Views, right? That's where I want you to put all of your pictures so that I can take a look, see, that, hey, yeah, it looks like this person, put in an hour of time this week. Sincerely appreciate it. And hey, look, I can maybe give a little bit of feedback on the things that I see here, right? So, I don't want this to be a huge stressor, right? An hour of your time over the next week is all that I'm asking for, right? I don't need to pretend that, you all are very busy people, and I appreciate that, but hopefully, this effort and what you'll be paid for with, your effort is some extra credit and hopefully a new skill, right? So, anyway. That brings us to the end of our first week's assignment. I sincerely appreciate your time and your effort, and I will see you all next time, okay? If you need any advice, any assistance, right, you can always come to us at the ITLP, right? Myself or any of my engineering coworkers are more than happy to help you, or you can contact me directly at mo.woods, that's mo.woods @colorado.edu. Thanks a lot, y'all. We'll see you next week.